In this lesson, we are going to look at magnetism. Magnetism can be defined as the property of certain materials to create a magnetic force, which will either repel or attract other materials with similar properties. It has also been found that some metals can be given these properties or magnetized. Metals with these magnetic properties are known as magnets. Magnetic materials are ferrous metals, such as iron and steel. Steel being iron alloyed with substances such as carbon, nickel, cobalt, chromium and tungsten. Non-ferrous metals, such as aluminium, brass and copper, cannot be magnetized. A magnetic field is the space around a magnet in which its magnetic influence is felt. Magnetic fields have distinctive patterns, caused by lines of magnetic force within the field. Magnets come in various shapes, and each will have its own particular magnetic pattern, although the strength of the magnetic force within the field may vary, depending on the degree of magnetism present. In the case of a bar-shaped magnet, the lines of force in the magnetic field produce the kind of pattern shown here, and we can see that the lines of magnetic force converge at concentrated areas near the end or poles of the magnet. A magnet will always have two poles because a single pole cannot exist by itself. The pole which points north is known as the north-seeking pole or red pole, while at the other end is the south-seeking or blue pole. By convention, it is accepted that the external lines of magnetic force or flux flow out from the red pole and into the blue pole. The stronger the magnet, the denser the flux. From our definition of magnetism, we know that magnetic materials will either repel or attract each other, and the rule to remember is that like poles will repel each other, whereas unlike poles will attract each other. Magnetism may be induced in an unmagnetized iron bar, and we will look at three methods of how this can be done. The first method involves stroking the bar repeatedly in the same direction with one end of a magnet. Note that the end of the bar last touched by the red end of the magnet is left as a blue pole. The second method is to align the iron bar with the lines of force in a magnetic field, and subjecting it to vibration or hammering. We can see the effect here. Note that the lines of magnetic force are directed into a blue pole and out from a red pole. The third method is a particularly effective method, and it involves winding a coil of wire around the iron bar and passing a DC or direct electrical current through the coil of wire. The coil of wire is known as a solenoid, and the current flowing in the coil produces a concentrated magnetic field along the axis of the coil, so that a high degree of magnetism can be induced in the iron. Now, having looked at ways to create a magnet, let's look at methods of demagnetizing a magnet. There are three main ways of destroying magnetism. The first is shock. This involves placing the magnetized bar of iron at right angles to the Earth's magnetic field and hammering the iron. The second way is to apply heat to the magnetized iron bar. Magnetism is lost if the iron is heated to around 900 degrees Celsius and does not return when the iron bar cools. And finally, if we use our coil of wire or solenoid again, but this time pass an alternating electrical current through the solenoid, the effect is that the alternating current continually reverses the polarity of the magnet. And if we now reduce the amplitude of the current to 0, the magnetism will be removed. Ferrous metals can be divided broadly into two categories of hard or soft iron. The terms hard and soft do not refer to the physical properties of the material, but to the magnetic properties of the material. Examples of hard iron are cobalt and tungsten steel. Hard iron is difficult to magnetize, but once magnetized, its magnetism will decay only very slowly, and it can therefore be considered for practical purposes to be permanently magnetized. Examples of soft iron are silicon iron and pure iron. Soft iron is relatively easy to magnetize, but the magnetism induced in soft iron is temporary and will only last while there is an external magnetic force present, such as in an electromagnet. This concludes the lesson. A summary of the main points to consider from the lesson follows. Metals with magnetic properties are known as magnets. Magnetism can be induced in some metals. Magnetic materials are ferrous metals such as iron and steel. Non-ferrous metals such as aluminium, brass and copper cannot be magnetized. A magnetic field is the space around a magnet in which its magnetic influence can be felt. A magnet will always have two poles. Like poles repel, unlike poles attract. The pole which points north is the north-seeking or red pole. Magnetism may be induced in an unmagnetized bar in three ways: stroking, aligning with a magnetic field and hammering, placing in a solenoid. Magnets can be demagnetized by shock, heat, reversing and reducing the current in a solenoid. Ferrous metals can be divided into hard iron and soft iron. Magnetism in hard iron is permanent and difficult to induce. Magnetism in soft iron is temporary and easy to induce.